Good evening. Today I will be discussing secure DevOps for Azure Functions and API management in hybrid cloud architecture. Where do you start? Cloud services offer more freedom and flexibility, but they create huge blind spots for IT security. Similar, the popularity of serverless applications come with their own challenges. Coupled with heavy usage of APIs and a microservices architecture does not make security simple. Tonight, in this talk, agenda will be introduction, where I talk and share details about myself. Then we move to cloud application security, technical controls, and administrative controls. And I will do some demos as well. My name is Lana Vyshnivetska, and I'm currently holding position of technical lead and challenger, a financial company in Sydney, Australia. I spent my professional life building software applications of enterprise level. I have 20 plus years of experience in software development and IT, experienced in software development lifecycle, solution architecture, secure DevOps, cloud technologies, and people management. I know there is no simple answer for all challenges in IT with modern technologies, but I'm very keen to help business utilize the best from IT and coach software engineers and IT professionals. You can find me on LinkedIn by simply searching my name, or use the link provided, or drop me a message in Gmail. So when it comes to technical controls, how to mitigate modern security threats using API management? What are subscriptions? How to protect your subscriptions keys and do not expose them to the wider audience? And how Azure Key Vault as a tool will help you to keep your secrets safe. Secure your backend using Auth2 protocol and JSON Web Tokens. Extract claims in Azure API management policy. Pipeline as a code. Why should everything be source controlled and no manual changes should be made in Azure portal? Certificates in API management, how they help you. In hybrid cloud architecture, connect on-premises API to cloud services by creating a facade which lets you safely integrate on-premises and cloud environments. What application firewall is, and how important monitoring in Azure, and why we need to log everything, all calls to APIM and down to Azure Monitor as a consolidated place. Administrative controls. What is segregation of duty model? What is ineffective incident response procedure? Also, we discuss application security testing as a part of your secure DevOps model. What are Azure Functions? Azure Functions is a serverless solution. System application logic implemented as ready to execute blocks of code. These blocks are called functions. Serverless computing means providing backend services compute resources on application's demand. This model lets the developer focus on the functionality rather than on infrastructure and maintenance. It helps to build features faster and reduce time to the market. It allows flexibility with hosting plans for your applications. As number of requests increase, as many resources and instances as necessary are allocated. As requests fall, resources and instances dropped automatically. There are three basic hosting plans available for Azure Functions: consumption plan, premium plan, and dedicated application service plan. All hosting plans are generally available on both Linux and Windows virtual machines. The hosting plan dictates the following behavior: how your functions applications is scaled, the resources available to each function app instance, and support for advanced functionality such as Azure Virtual Network connectivity. API management is a gateway between clients and backend services, allows organizations to publish APIs to external and internal parties, provides a certain interface to consolidate and manage thousands of APIs across multiple platforms. Definition by Microsoft: accepts API calls and route them to your backends, verifies API keys, JSON Web Tokens, certificates, and other credentials, enforce usage codes and rate limits, transforms your API on the fly without code modifications, cache backend responses, and logs call metadata for analytic purpose. Building facade and decouple between internal backend and external services, or to allow integration with third-party partners, provides security and protection for your APIs. API Management Security Baseline already defined by Microsoft and should be implemented in collaboration with your network engineers. As application developer, you should take care about following: protecting critical web applications. API management should be confined with virtual networks in internal mode. And an Azure application gateway should be configured. By using this gateway, developers can control access to critical web applications. Denying communications with known malicious IP addresses. By using application gateway, developer can prevent access to malicious IP addresses. Role-based controls should be used to restrict access to Azure API management. APIM has following capabilities. API management products. Products are how APIs are surfaced to developers. Products can have one or more APIs and are configured with a title, description, and terms of use. Products can be open or protected. Protected products must be subscribed to before they can be used, while open products can be used without a subscription. When subscribed, users get a subscription key, which is good for any API in this product. Groups are used to manage the visibility of product to developers. Can be administrators, developers, or guests. As you can see, Azure API Management Service Providers has many security and performance features. For example, based on API access plan, it can limit the number of calls that are allowed per the plan, prevent denial of service attack by using throttling, secure backend services by gating access with the API keys, allow to use advanced security policies like JSON Web Token certificates and other credentials. Hybrid cloud overview. My personal experience is with Azure Express Route to create private connection between Azure infrastructure on your premises. As you can see, Express Route circuit here and Microsoft Edge routers and gateway subnets, web tiers, business tier, data tier on cloud side with a virtual network. On the left, you can see on-premises network where you can configure your own gateway and access to your servers, for example, database server. You can separate internal and external connections as well. When your internal customers are coming to service endpoint inside your API subnets, you have virtual network where you can separate subnets and access to them. And for external users, you configure application gateway subnet as well, where you put your application gateway as your first line of defense. When it comes to serverless applications, does it mean you have no servers, no attacks? Actually, that's not the case. Threats for your applications are still there. They just look and act different way. Serverless applications can include hundreds of functions, meaning your attack surface has changed. To keep control and maintain security require higher maturity level. Secure DevOps as a cultural thing shift in a way of thinking. These days, the overall shift of responsibilities with hybrid cloud architecture resembles cloud provider, who is responsible for physical security, host infrastructure, operating system, logical application server, cloud customer responsible for application logic, client endpoints, and data. And what is shared between them is network controls, identity, and access management. As you can see, still plenty of things we need to be responsible for. OWASP Top 10, they still apply for serverless and hybrid cloud architecture. To help you to streamline and bring your security on high maturity level, make a right grouping for function apps. Grouping means collection of functions that share code, configuration, or management. These allow you to grant least privilege. Leverage any of security features built by your cloud provider. For example, Azure Security Center, managed identities. Later, we talk about application firewalls, restriction of IP addresses, what tools can be integrated with your CI/CD pipeline, and how to shift mindset and ally practices with a secure DevOps model. Zero trust model, security development lifecycle, and Know your stakeholders. In general, zero trust approach aims to wrap security around every user, every device, every connection, every time. Identity and access management is the first step in enforcing your security policies for users. Zero trust assumes there is no traditional network edge. Network can be local, in the cloud, or hybrid with resources anywhere. However, networks, the enterprise resources and data need to be segmented and continuously monitored for intrusions and anomalies, not typical behavior. When it comes to your application, least privilege access must be enforced for all private applications and accounts in the cloud or on premises. With devices, end-user device must be isolated from each other, protected from threats, and continuously monitored. When you integrate your security into DevOps, you start with plan, where you define your threat model policies. In a coding and implementation phase, you include your static analysis. Then you do code review, and when it comes to build, it is suggested to move your penetration testing earlier. In traditional model, we do penetration testing at the very end, sometimes even after go live date. But you can actually do this in between your stages, for example, from moving to UAT to staging, or before moving to production. You test and release, and then you deploy, where your log and audit come into the play. In operate mode, when your application is live and running, you should do your threat intelligence and continuously monitor and detect and respond if security breach occur. Who your stakeholders are. Business division. What level of knowledge in security they have. Start small, plan to scale. It works well in Agile, doesn't work well in waterfall project approach, where everything should be estimated and budgeted upfront. Take as many opportunities as you can to talk about security on business level. They might start to educate themselves and embrace your idea on company level. Talk from positive side, how cybersecurity will strengthen in the business and helps to succeed. Define what security controls required. Start early on project discovery phase. Do upfront security assessment. If you don't have resources to do so, invite professionals. Be enabler and build knowledge base for everyone who is interested. Explain on different levels from basic to advanced. When it comes to general security guidelines for application developers, very obvious you have to validate your input for your Azure functions. Apply least privilege principle. Designating group of individual roles responsible for specific functions. Monitor third-party dependencies. Take components only from official sources over secure links. Prefer signed packages to reduce the chance of including a modified malicious component. Secure your cloud storage. Add multi-factor authentication, data encryption, SaaS tokens. If you keep your client's documentation in blob storage, Azure Blob Storage in Azure Service to store files, then leverage shared access signature tokens. This type of access tokens grants restricted access right to Azure storage resources, where client application granted permissions to manipulate with the resources in storage. It also valid for a certain time only. Enforce authorization and authentication, no direct access call to Azure functions, only via API management. Configure network security rules for inbound and outbound communications. Configure transparent data encryption, especially important in hybrid architecture when SQL servers are on-prem. Subscriptions in Azure are Azure Tenant, Azure Subscriptions, Azure Resource Groups. An Azure Subscriptions is a logical container used to provision resources in Azure. It holds the details of all your resources like virtual machines, databases, and more. Azure Tenant is a higher level of the Azure subscription hierarchy. This is represented as a single identity, for example, person or company. Tenant is linked to single Azure ID instance. One tenant can have multiple subscriptions. Azure subscription is at the level at which the customer is billed based on usage. It also provides a logical segmentation for simplifying administration and access, should be designed having security consideration in mind, aligned with segregation of duty approach. Typically, a company can have a single tenant, and each of the departments using cloud services can have subscription for their respective Azure environments. Azure Resource Group help in creating logical and billing segregation for resources. Each resource group can have different administrators to track billing. The billing data for several resource groups are collated and sent as a single invoice and can be managed much more easily at the subscription level. What are types of Azure subscriptions? Sponsored or trial subscription, access to certain resources provided for a limited period of time or provide a certain amount of credits. Pay-as-you-go Azure subscription is the most affordable form of paid subscriptions, most widely used method. Enterprise agreement Azure subscription. There are high volume licenses and some level of commitments. But what we discussed today in particular is APIM subscription and how they can protect Azure functions. Issuing subscription key is the most common way for API consumers to get access to APIs published through an API management instance. Think about subscription as API key. Client must have a valid subscription key and HTTP request when they are making calls. Provide a name for subscription scope, for example, all APIs, individual API, or product. Restrict the access to subscription key values in staging and production environments, so only authorized persons can see the value. Let's have a look on example. You can specify your APIM instance name for different environments in your parameter file for dev and UAT separately. And when it comes to subscription, as you can see, you can define type and scope. Is it internal or external? Here, API1 subscribed to my API as internal, and API2 subscribed to my API as internal, and similarly, API3 subscribed to my API via internal scope. Segregation of duty models. What this model is, concept of having more than one individual required to complete a task. It will help you to protect your subscription keys and more, and do not expose them to entire development team. Keep your audience small. This is an internal control which is intended to further reduce the risk of fraud and security risk, sometimes known as redundancy. General approach, purpose and principles. Privileges are divided among multiple professionals so that no single individual is proficient to control the process. By allowing more than one individual to perform any given task, an organization can minimize the opportunity for misconduct, unintentional error, and security breaches, increases the opportunities to identify it. The key principles that can be applied to segregation of duties are sequential separation, when an activity is broken into steps performed by different persons, for example, deploying to UAT and production environments. Individual separation, when at least two persons must approve an activity before it's done, for example, release management process. How separation of duties align with Agile, maximizing efficiency, reduce time to the market, and unnecessary costs. Separation, if separation of duties works well with continuous releases approach, when release to production can be done multiple times per day. It certainly creates difficulties for secure DevOps team, and there are some limitations how this concept works with continuous release and continuous delivery process. In general, it depends on your company culture and existing release governance process. It might be a formal release process established in banks, financial institutes, and highly regulated companies, where several days can go from the change request to the actual production deployment. In this case, segregation of duties is an ideal model which will allow to control production environment and reduce security risks. From the other side, and based on my personal experience with different industries, when continuous releases is a practice and company is doing multiple production releases per day, and time from coding to production is reasonably short, this might be a suboptimal model and creates an overhead. That types of companies can see more benefits and gain from going to production faster and reduce time to the market, especially in e-commerce. Still possible when a secure DevOps team controls the last step of production deployment. Decisions should be made individually based on your needs. JSON Web Tokens. Secure your backend using Auth2 protocol and JSON Web Tokens. Validate tokens against well-known endpoints of your identity provider. Extract claims in Azure API management policy. Expired registered claim is included in the JWT token unless required expiration time attribute is specified and set to false. Policy requires an OpenID connect discovery endpoint to be specified via an OpenConfig element. API management expects to browse this endpoint when evaluating the policy, including JSON Web Key URLs in the response to discover the public key modulus and exponents. If you implement custom authorization or auth solution, it is recommended to implement OpenID Connect Discovery endpoint too and validate your token against it. So here you can see example when we define our external gateway provider API key name and audience name. Let's have a look on another example, how you can extract policies. So basically, you use your XML with a when condition, and you check if your token contains authorization key, and you throw unauthorized response if it doesn't, and you check your authorization key. And here you try to parse your JSON Web Token by extracting custom claims, such as customer ID or user ID or user roles, and pass it down to your API as an input parameter. There is a capability to protect APIs using client certificates in API management. Options to manage certificates are: reference a certificate managed in Azure Key Vault, add certificate file directly in API management. Using Key Vault certificate is recommended way because it helps to improve API management security. However, examples here illustrate certificate uploaded to API directly with a thumbprint kept in Azure Key Vault. Validation of this certificate done in C# code by implementing custom validator. And that's how certificate can look in API management with expiry date and a thumbprint. And in ARM templates, you can specify your Key Vault where you're taking value from. Azure Key Vault is a good tool to keep your secrets safe. As been mentioned, different types of Azure functions require different security measures. You can keep your subscription keys and API keys in Key Vault. You can also put your connection string there and other details such as passwords, client secrets. Connection strings between Azure function and data source, for example, SQL database, can be kept a secret, and it is a good practice to separate key vaults from different environments. As a general guideline and reminder, never leave valuable information in the source code configuration files, README files. Pipeline as a code and why everything should be source controlled and no manual changes should be made via Azure portal. Let's start from a distance. For every project where we apply secure DevOps, we do upfront assessment, which includes initial risk assessment, audit, compliance, what controls needs to be enforced, and boundaries. Threat modeling, where we assess risk in iterations, attack surface, identity management, access software, supply chain, delivery pipeline, includes repositories, NuGet servers, plugins, artifacts, and connections. Keep delivery pipeline configuration, which builds, tests, deploy applications where software infrastructure treated as a code under the source control and represented as reusable components. Two aspects here, security of the pipeline and security in the pipeline. Security of the pipeline includes permissions, version controls, transparency, consistency of deployment, and one location for all. Security in the pipeline includes your vulnerability scan, peer reviews, access to related resources, approval for every development steps by relevant authorities. Related to SecDevOps, when you can incorporate security as a code methodology here as well. For example, reference an ID of KEYVAULT secrets in your resource templates. Second example is security scans implemented in a pipeline. Please note, these practices are not only relevant for microservices and backend, but also can be adopted to the micro frontend as well. Azure Web Application Firewalls on Azure Applications Gateway provides centralized protection for your web applications from common exploits and vulnerabilities. Web applications are increasingly targeted by malicious attacks that exploit common known vulnerabilities. SQL injections and cross-site scripting are amongst the most common attacks. Configure your API management service in a virtual network in internal mode, making it accessible only within the virtual network. Azure Application Gateway as platform as a service, acting as a load balancer. It provides a monolith offering a web application firewall. By combining API management provisioned in an internal virtual network with Application Gateway frontend, you can use the same API management resource for consumption for both internal and external consumers, use a single API management resource and have a subset of APIs defined in API management available for external consumers. Provide a way to switch access to API management from the public internet on and off. Azure Monitor is a consolidated report on all the Azure entities and on-prem ecosystem is required. In other words, it's a centralized solution to monitor Azure applications, manage and secure hybrid cloud resources. Best practices enable monitoring for all applications, integrate monitoring into pipeline, group service and resources into resource group, retain logs for audit and compliance purpose. Advantages. It allows advantageous analytic engine and a rich interactive query language. Automatic notification response to critical issue, create rules and detect conditions across the data collected, and optimum costs. Information on security events helps to understand and prioritize threats based on what is happening in production. This is an example of someone tried to probe API endpoints and see if they can get admin-like access. Watching for runtime errors and exceptions and attack signatures show where applications are being probed and tested, what kind of attacks shown and what part of the code need to be protected. Other tools can be considered too, for example, Serverless 360, Application Insight, Service Bus Explorer, Log Analytics. Anytime when it comes to web application development, scheduled functions, data transformation jobs, we need to think holistically how to combine static, dynamic, and interactive analysis security testing tool to improve OWASP top 10 security vulnerability detections. Do the basics like fixing known vulnerabilities and hardening your systems to decrease the likelihood of getting attacked, as well as implementing runtime protection to detect and respond to post-vulnerability exploitation and other in-memory attacks if they occur. Add a static application security testing to development lifecycle, to every commit, to catch defects early. Find known and very obvious pattern of vulnerabilities in the source code. Should be very careful how to set up policies, as these tools are known for many false positive alerts and making noise for minor software flaws and unexploitable defects. However, it teaches developers how to use secure software patterns to avoid insecure, infrequently patched code libraries and explain how to repair potential vulnerabilities. Dynamic application security testing is more suitable to a waterfall approach, but Agile can benefit too. Dynamic testing detects vulnerabilities by conducting attacks against a running instance of the application, simulating the behavior of an attacker. And this tool does black box testing. Interactive analysis security testing uses agents and additional software libraries to collect data from running application, and it can reveal some potential vulnerabilities. It works inside the application and different from static and dynamic scans. It does not test the entire application or code base, but only whatever is exercised by the functional test. It runs as an agent and allowed to collect and then analyze event data. Benefits from these approaches. It reports findings in real time for the scope of the application being tested. It's good for API testing and especially for Azure Functions and microservices. Promotes reuse of existing test cases. Avoid the need to recreate scripts for security testing. In most cases, you should run both static and dynamic application testing, or you can consider a hybrid approach. It merges and correlates the result from static and dynamic tools to focus your effort on the vulnerabilities that matter most. Prioritize other findings and deliver an efficient approach to application security testing. Penetration testing could be included in early stages and can be conducted by external vendor. Secure DevOps based on shared responsibilities model. At the end of the day, this is team responsibility. Security comes first and integrated in every stage of software development lifecycle. We should remember that failure is going to happen, so here we can address our risk appetite and level of tolerance. Open, blameless communication not only inside security team but across development team. Getting right people start working on incident immediately is the basis of your incident response. It consists from 6 stages or steps. Preparation, most crucial step. Ensure your staff and stakeholders trained regarding their incident response roles and responsibilities in case of data breach. Develop incident drill scenarios and execute mock data breaches on regular basis. All should be planned and funded in advance. Identification. This is where you determine whether you've been breached. Could originate from many different areas. When, how was discovered, who discovered, are the areas impacted, what is the scope compromised, does it affect operations, point of entry. All of these questions you have to answer on this step. Containment. Do not destroy evidence. Contain the breach so it doesn't spread. Disconnect affected devices, applications, servers. Prepare short-term and long-term containment strategies. Eradication. Find and fix root cause of the breach. Has the system been hardened, patched, and updated, or your code fixed? Recovery. Here you restore or redeploy affected systems and the application. Lesson learned. Think about rapid learning when incident happen. Every occurrence helps you to tighten your security posture by introducing new tools and security practices. Post-incident review meeting will help you to evaluate cost of the incident and reputational damage. What weaknesses this breach exploit? How to ensure this not happened again? What changes required in your secure DevOps cycle, or should it be applied on enterprise level? These are all points for today's talk. Thank you, and I would like to hear feedbacks and questions.